Today we are looking at the history of the National Electrical Code, or NEC. In the late 1800s, America raced toward the future, but with dangerous, untested wiring. Fires and electrocutions were common because there was no standard for safety. This chaos couldn't last. Today we dive into the history of the NEC, the rulebook that saved modern America and became the foundation of electrical safety. By 1896, 5 competing regional standards caused confusion. To solve this, insurance agents, electrical engineers, and architects met to forge a single national code. The result, in 1897, was the first NEC, a thin 58-page document focused on fire prevention in commercial buildings, laying the foundation for modern electrical safety. In 1911, the National Fire Protection Association, or NFPA, assumed sponsorship of the NEC. The NFPA introduced a formal consensus-based process involving inspectors, engineers, and manufacturers. This ensured the rules balanced safety, practicality, and enforceability, transforming the NEC into an authoritative national standard. In 1937, the NEC was reorganized, establishing the modern format we use today. The biggest change was the creation of Article 250, making grounding a central pillar of electrical safety. The code mandated that continuous underground metal water pipes be used as the grounding electrode, providing a reliable earth reference for the first time. In 1962, the NEC mandated 3-prong receptacles for new circuits. This addressed the rise of metal-cased tools, which could become electrified if insulation failed. The equipment grounding conductor, or EGC, ensured current instantly tripped the breaker, preventing severe shock. This ended the era of risky cheater plugs and unprotected users. By 1968, the NEC established a rigorous revision schedule. It would be updated every 3 years. This commitment ensures the code keeps pace with technology, new installation methods, and real-world accident data, keeping it a continuous, living standard for public safety. The 1971 NEC introduced ground fault circuit interrupters, or GFCI, for outdoor receptacles. Standard breakers, designed for fire prevention, would not trip from a lethal shock current. GFCIs monitor the circuit and shut off power in milliseconds if a tiny amount of current is missing, protecting the person from deadly outdoor hazards. The 1987 expansion of Article 250 was driven by the personal computer revolution. To solve interference issues, the NEC clarified the use of isolated ground receptacles, the orange triangle outlets. This provided a clean, dedicated ground path without sacrificing safety. The code also formalized the two-rod rule to streamline the grounding process for most residential jobs. In 1999, arc fault circuit interrupters, or AFCI, were added to prevent electrical fires caused by arcing. Since arcing pulls little electricity, standard breakers wouldn't trip. AFCIs use a computer chip to analyze the waveform and shut down the circuit before the arc ignites surrounding materials. This marked the NEC's transition into the digital age of safety. The 2011 NEC, often called the Green Code, recognized renewable energy as mainstream. It created Article 694 for small wind electric systems, standardized DC arc fault protection for solar to prevent roof fires, and overhauled Article 625 for electric vehicle charging, ensuring the charging plug is dead until it locks into the car. The 2017 NEC added Article 706 for energy storage systems, a direct response to the lithium-ion battery boom. Recognizing the risk of thermal runaway, the new rules required systems to be tested as a complete unit. They also mandated smart disconnects so first responders could instantly isolate the volatile batteries during an emergency. In 2020, Article 625 was renamed Electric Vehicle Power Transfer Systems to address bidirectional charging where a car acts as a power source. New rules ensured the car wouldn't electrocute linemen if the main power failed. It also clarified energy management systems, allowing safe installation of chargers on smaller electrical panels. The 2023 NEC introduced Article 726 for digital electricity, allowing safe transmission of high voltage over thin cables. It also mandated cybersecurity evaluations for network-connected safety equipment. Finally, it reinforced the need for an emergency disconnect outside homes with solar and batteries for first responder safety. The NEC serves as the single standardized safety benchmark. It reduces risk by eliminating known hazards and standardizes work, ensuring a common level of quality in all jurisdictions. This provides a universal framework for manufacturers, contractors, and inspectors, maintaining a consistent level of public safety. The NEC is created through a structured consensus-based process involving inspectors, manufacturers, engineers, and labor groups. This multi-stakeholder consensus ensures the code balances safety, practicality, and enforceability, allowing it to be continuously updated and recognized as the definitive national standard. The NEC is a living document, revised every 3 years in response to technology and real-world accident data. Because the code is constantly changing, continuous learning is required for all professionals to maintain public safety and professional competency. Electrical safety is a continuous effort of adaptation and education.